Thank you for being here. Thank you for attending my talk. I'm Tudose. I welcome you to this integration testing with Spring talk that we are going to watch now together. A few things about myself to briefly introduce. I'm currently acting as a Java and web technologies expert in Luxoft in Romania. I have a PhD in computer science, and my current activity is mostly dedicated to spreading the knowledge about the technology. I'm currently conducting courses inside our company. I created the courses and the project for Pluralsight, and I wrote these two books for Manning, JUnit in Action, published in November 2020, and Java Persistence with Spring Data and Hibernate, published January 2023. So our talk is really close to my usual regular activities. To introduce you about testing now, we talk about integration testing. This is the topic of our talk today. And we would like first to place integration testing in some pyramid, because we may talk about a testing pyramid. When you are testing your application, first of all, you need to make sure that the individual units, meaning classes and methods, are really working fine. This is the first level of our testing here, unit testing. Integration testing, that is our main topic today, is on top of the unit testing, and we would like to make sure that our units correctly integrate together and with third-party things, because it is possible that they work individually very well, but they do not integrate correctly between them or with other things like external services, databases. Here we are going to have a closer look about what we can do with Spring. System testing means that you would like to test your whole system after assembling all its pieces together. And just to mention also the top of the pyramid, acceptance testing is the testing from the side of the end user. You will ask yourself, okay, my application is correctly working, but does it address the real needs of the end user? Does it satisfy the expectations of the user? Does it address the way the user interacts with the application? But as I was saying, we are going to focus on the second level of this pyramid, integration testing. And in order to do this, we are going to use this Spring TestContext Framework. You will see it immediately in action. We are talking about a generic annotation-driven integration testing support from the side of the Spring. We say that it is agnostic of the testing framework. In our demonstrations, we are going to use it together with the most widely used testing framework in Java nowadays, JUnit 5. And saying this, I'm going to switch to the demo. It's a danger. Yes, sorry. Prepared here some applications that we are going to demonstrate on. Simple applications for our demonstrations. We have here some user entity. We plan that our Java application integrates with a database. This is part of the integration idea. We work with our application that is interacting with the database, persists, retrieves data from the database. And this is something like an external thing that the application needs to integrate with. The user entity is having some ID, name, very simple things, but very useful for our demonstrations. And we defined this user repository. In Spring Data, when I define such a user repository to extend JPA repository of user and long, it may be translated in plain English that my repository is managing entities of type user, having IDs of type long, which is exactly what we have here. So just by defining such a repository, we are already inheriting a lot of behavior. Because if I go here, I see that the JPA repository is already defining a set of methods. Yes, that it is also inheriting from here, that is defining all these methods are inherited by my user repository. And when I will come here to auto-wire such a user repository, Spring will create a proxy implementing this user repository interface, and that already has the methods created to do what? Exactly to find, to do the basic CRUD operations in general. Create, read, update, delete. So just by defining such an interface and by injecting auto-wiring here this user repository, I will immediately get, in 1 minute, I can get the whole suite of the basic CRUD operations. And for our demonstrations, remember, we would like to check how to integrate with an external database. I created here the configuration. I am trying to integrate with a MySQL database. I have it installed here on my machine. This is all the configuration that I have. Say, okay, this is the URL, the credentials, talk to the database in its own dialect, and show us the SQL that we are going to create. And I came here, and using this user repository that I injected, I'm trying to save an entity, then to retrieve it and to assert that indeed what I'm getting is size 1 and it has the expected content. Test is this JUnit 5 annotation. The test works fine. So if I will run it again and again, say, okay, everything is fine. I can even see here the generated JPQL queries as I was asking here. Show this ones. Okay, so if I'm running this test again and again, I'm fine with interacting with application. Why not use, in this case, this repeated tests? Because if I run it several times, I have reasons to presume that if I am running it twice at one shot, I will be also successful, yes? Let's see what it is going to happen. Surprise or not, the test is successful the first time and it is failing the second time, saying I was expecting only one record there, only one entity, but I received 2. So what is happening here? We are having a problem with the integration with our database. Because if now the tests are run using this repeated test, one after the other, without reinitializing the Spring context, it means that something remains dirty behind us. So we come back to the database with the second running of the test, and we find something dirty. We found the record that was already persisted in the previous test. So it means that we do not integrate correctly with our database. What's to be done here? We don't want to leave things uncontrolled. We need to know that we are running on a well-known context. Okay. What to do? Which are the alternatives provided by this Spring TestContext Framework? We have the possibility, first possibility, to use this dirties context annotation. It tells us that the underlying Spring application context has been dirtied during the execution of the test and should be closed and recreated for any test. If you would like to see exactly how it works, we repeat here for each test. We create context and cache, inject dependencies, so auto-wire those things annotated, user repository in our case, execute before each test, after each, remove the cache context, and we repeat things. Yeah. This is the cycle that the dirties context will force to happen. So I go back here to my application, and I will introduce this dirties context, say, okay, reinitialize the context just the way we were presenting here, to remove the cache context and recreate it at the beginning of the execution of the next test. Let's see how things are going now. Okay, this time we are having 2 successful executions of both tests, because before each repetition, the context is reinitialized. So we do not get the old records that were breaking our test. By coming with this dirties annotation, the dirties context annotation. Now the question is, how feasible is to come with this dirties context annotation? Does it come at some costs? And the answer is, of course, yes. Nothing is absolutely free. Introducing this dirties context annotation will come with some costs, because reinitializing the context this way several times is, of course, time-consuming and resources-consuming in general. It's an alternative. We can use it, but we are looking for other alternatives that may be more efficient. And one other alternative is to use this transactional annotation. What are we talking about here? We are testing our application. Our application tries to integrate with the database. If at the end of the execution of a test, we make sure that everything is rolled back, it will mean that we are leaving our database in its previous state. So we don't leave anything dirty. We may come again and again with our new tests to find the database in a well-known state and to integrate correctly with it. And a second alternative is to use this transactional annotation to execute our tests transactionally. What do we mean here? We have here some other test that we annotated with this transactional annotation. This is also a Spring annotation. In essence, what is a transaction? A transaction is something having the acid properties. A is from atomic. So either you execute everything or you do not execute anything at all. For executing these tests, when I am using this transactional annotation, by default, because of the existence of a listener that we are going to come back, the execution will be transactional. Everything will be done. We are going to check whatever we would like to check. Yes? And then the transaction will be rolled back by default because of the existence of a listener that is taking care of rolling back. This way, we make sure that we do not leave things dirty behind and that the next test will correctly integrate with the database. So let's see. Here I already have this repeated test annotation. Let's see how this works here. Okay, 2 repetitions are correct. And I would like to have a look in the logs because I printed something, transaction active. So before all, there was no transaction. Before the execution of the test, the transaction is active. At the end of the method, the transaction is active. And we are following this cycle. So each execution of a test is inserted in a transaction. Because at the end, of course, after all, there is no active transaction. At a first sight, using this transactional annotation looks better than using the dirties context. And I made here some experiments. You see, by executing several suites of tests, we see the difference for a number of, starting from 100 rows to 2,000 rows that we executed with MySQL dirties context versus transactional, and with H2 dirties context versus transactional, we always have shorter times with transactional because reinitializing the context as the dirties context annotation forces us to do is a costly operation. And one more thing to notice here, you see here the third bar here is approximately constant. So this is the difference between the time execution with MySQL and the time execution with H2. And it is pretty constant from 100 rows to 2,000 rows. Why? Because this difference does not depend on the number of rows, but on the number of the executions, because you need to reinitialize the context 10 times. We are running the test 10 times. We don't care about the number of rows, but we care about the number of reinitializations of the context. And dirties context comes with pretty high price. Probably you should keep in mind that you shouldn't push code using dirties context annotation on your continuous integration, continuous deployment machine, because it will take time to execute always this test. Maybe you will do it locally and you will prefer the usage of this transactional annotation. Okay.
transaction annotation also looks considerably high compared to non-transactional execution. If we just compare the transactional execution against the non-transactional.
No, this is the difference. The third bar is not non-transactional execution. The third bar is the difference. Let me see if I have here my pointer or not. How can I show you my cursor? Aha, okay, here. So this first bar here is the dirties context annotation execution time. This is the transactional, and this is the difference between them. It's not non-transaction.
I changed my question slightly. This difference probably mostly caused due to the recreation of the context.
Yes.
What is the rest of the cause for the increase of the transactional execution?
Here it increases because of the number of rows. If you're so here we have from 100 to 2,000 rows.
But it's same for dirties context as well.
Yes, of course. When you work with 100 rows, you have some time. When you work with thousands of rows, you have some.
I suspect did you employ connection pooling in your benchmark execution?
No, but that would be an idea. Thank you. So I was saying that transactional anyway comes with these advantages, but we have to have a closer look at some risks that it involves. And I'm going to come back here to this piece of code, and probably something that at the first sight we didn't notice. I inserted this call to this user service transactional method, whatever. If I look here, I introduced this user service. I auto-wired here this user repository. I made this method transactional, and I am happy with it. But why am I happy with it? Because with this transactional execution, the execution of this test is transactional. If I'm calling here another method that is transactional, like here, user service, what will happen? Say, transactional by default has propagation required. If I arrive here with an already existing transaction, say, is the propagation required? Yes. Do you have an existing transaction? Yes. Then I will continue with it. And it will execute this transaction, this save within the same transaction. At the end of the execution of this method, it will roll back that transaction. And that is good because we do not leave anything behind us in the database, and we integrate correctly with the database. But in Spring, this transactional annotation may have some different propagations. And I come here with propagation requires new. Let's first, so I'm forgetting about the default propagation. Let's execute now this test. Second execution is failing. Says here, I was expecting 100 rows and I found 101. Why? Because this execution is on a different transaction. I have here a picture. Transaction T1 is, transaction 1 is the transaction from the test. We suspend it when we call that other transaction that requires new. that user service dot transaction method is executed on the right side transaction, on transaction 2. That transaction is committed. We come back to transaction 1. We continue it. We roll back transaction 1, but transaction 2 was a separate transaction that was committed. So if you work with the transaction annotation, make sure that you are really executing your test within one single transaction, because any separate transaction may commit and may ruin your tests and your integration with the database. We still have more things to see. I can manage here my transaction using this before transaction, after transaction annotations. By default, a transaction in a test is rolled back because its role is to be executed to allow the checking and at the end to leave things clean behind it. I may eventually use this commit annotation, but in most cases you will not want this because we are talking now about testing, not about the real life application when you get transactions that you need to commit. You want to test, you want to check that your application is correctly integrating with the database, and after working with the database, you leave things clean behind you. Okay. We have the next step in our discussion about listeners. We would like to create some side effect methods. Of course, we have the possibilities of working in our tests with the before all, before each, after all, after each methods, after annotations. But using these listeners will provide us the possibility to isolate some behavior, to put it in such a listener, and to reuse them for several tests. How can we do this? I have to create my own listener here that is implementing this test execution listener. You see, this is an interface having a lot of default methods that are otherwise not doing anything. And I created my own listener. For the moment, I'm just looking at transaction active. I'm just printing some messages to know that I was there. This is my listener. And I'm coming here and I say I would like to use my listener on some test. For the moment, I will pretend that this is not here and that I just annotated my test with transaction listener and I'm specifying this newly added listener. And I'm executing a test that is really similar to what we noticed so far. Test fails. And if I look here, it says null pointer exception cannot invoke whatever user repository is null. User repository is the one that was injected here. Now, the auto-wiring does not work any longer. I will look here for something that I printed. You see, this listeners, the size of the listener is 1 here because only this one has been created. We can add this dependency injection test execution listener here. It was previously added by default. And I can rerun the test. The test seems to work, but I'm looking for something else now. I'm going to look to see if I have a transaction here, because remember, our test is annotated with transactional. Say transaction active false, false, no transaction, no. Why? Because remember I was saying that the transactional execution is due to an existing listener that is registered by default by Spring. How many listeners do we have here now? We have 2 listeners. Sorry, I can add here this transactional test execution listener that was previously registered, but not any longer. Now, if I look at the transaction execution, I see that finally a transaction is created here. Because in the absence of this transactional test execution listener that was previously registered by default, it doesn't care about this transactional annotation any longer. It will just do it non-transactionally. And if I look here at the sizes of the listeners, it is 3. 1, 2, 3. But do I have to come and to re-register manually all the previously existing listeners? I have a better alternative, and I'm going to go back here. Say here, I can add this parameter, merge mode, merge with defaults. There are already some default execution listeners that are registered there, and that I want, when I come with my own listener, I don't want the other listeners to be unregistered, but I just want to merge with them. So let me rerun the if I'm looking here, size of the listener is 15. So I have 1 listener from my side and another 14 that come by default. And this should be for sure the best of. If you want your listeners for a good integration, that's fine, but don't forget to merge them with the existing default ones. Okay, and one more thing. Just one more thing in our demonstration about doing good integration with the help of the active profiles. Have another example here. I am using the profiles that are defined by Spring Boot. By default, Spring Boot keeps its configuration in such an application.properties resource file, and it may define separate configuration in application-name of the profile.properties. And in a very realistic scenario, I may have this situation. I have the developer that is running against a database and is trying to integrate with that database during development. And I'm having the production profile here that is running in production and it is trying to integrate with a real database MySQL. During the development, you would like to be quick. You would like not to waste resources, to have a lot of configuration on your machine. And it is very realistic to have some light in-memory database like H2 to integrate with it during your development. When you move to production, what would you like to do? You would like to very quickly switch between these configurations. In production, of course, you will use a real database. What's the solution to do this testing quickly and switch quickly between the configuration, the light configuration of H2 development to MySQL production? I can specify here the active profile. What's the big advantage here? The code remains the same. The tested code is untouched. I'm having my tests here. I would like not to touch the tests. I would like to integrate with two different databases without touching the code, the base code, and without touching the tests. I just switch between the profiles here. So if I am having here a dev profile, let's have a look. So this is having H2 here, and you see everything is done with the H2 database and with H2 dialect. And I then move to the production. I just need to switch here the active profile. I don't want to touch the code, neither the base code nor the test. And here I am MySQL here, dialect MySQL. So it is using the other database just by switching from the configuration. There is another possibility that I use this active profile, the active profiles annotation that is overriding whatever I'm having here, but in this case I need to change the code of the test. Not very much applicable in real life, but just we have to know about its existence and to make sure that if we want to run on some profile, there is no test that is overriding the original configuration. So this is a way how to integrate our applications very quickly in different situations on different profiles and how to switch between these configurations. So that ends the demonstration. Thank you, and I'm looking forward to questions.